Hey guys, so let's start. Good afternoon, everybody. So last time, okay, guys. So last time I started to explain how can we use the keypad. As you see here, we have a keypad here. I started to explain how can you use it. Okay, so simply what I told you last time. So if you see here, this keypad has 16 push buttons. 16, right? I already explained to before how can you use push buttons. Is that okay? So the very naive idea for 16 push buttons. So I'm going to use 16 pins. I'm going to use 16 pins. I'm going to use one pin for each push button, right? So this is a very naive thing for sure, because we don't have too many pins to just use 16 for the keypad, right? That is why we used a different idea last time, very interesting idea. Because of this idea, we can reduce the number of pins from 16 to only 8, okay? By making something like a grid, okay? So what we did last, this is how usually we connect the keypad. So the idea here, as I told you, we have here conductors, wires, whatever you want to call them. Also, we have here 4-wire and 4-wire, okay? As I made it very clear last time, okay? So every intersection here is not a short circuit. It's not a short circuit, okay? Every intersection is not a short circuit. Sometimes we make it this way, sometimes, you know, we make something like this one. But anyway, I'm telling you, every intersection here is not a short circuit. Otherwise, all of them are going to become 1 point, okay? But anyway, so what I'm saying here, what we are going to do is, so we have we call four rows, and we have four columns, as you see here. Okay, so what is the idea? The idea, so now I need pins here. Okay, so I need 4 pins and 4 pins. Okay, so this so also these ones are going to be connected to the microcontrollers. Okay, however, these 4 are going to be sorry, I think these 4 are going to be input. Okay, and these 4 are going to be output. Is that okay? So I'm gonna, now I need 8 pins, 4 of them input, 4 of them output. Okay, I'm gonna tell you why I made 4 input and why I made 4 output. Okay. Okay, so what is the idea? The idea is that, as you see here, guys, every switch, we have a switch here in every intersection. Okay. So the main idea is that when you press a switch, you are gonna actually connect one row to one column. Electrically, you are gonna connect them. You are gonna make it. So when you press, so actually this you are gonna make a short circuit here. You got what I'm saying? So when you press, you are gonna make a short circuit between one row and one column. We don't consider the scenario that you are gonna press 2 at the same time. We're assuming you are gonna press only 1. So if you press only 1, the one you are gonna press is gonna be a short circuit. All the other ones are gonna be open circuit here. Okay. And then all what I need to do now, if you are pressing, if you are pressing a button, all what I need to know which row is connected to which column. That's it. Why? Because every switch has a unique pair of row and column. You understand what I'm saying? I think it's very clear. So this is row 0, column 0, column 1, column 2, column 3. Okay. So every switch you see here, every switch has a unique pair from column number and row number. Is that okay? So usually the way I'm going to explain, or the way we do it is, we do what we call scanning. We need to scan, because I don't know which row is connected. I don't know what is the short circuit. So I have to find the short circuit. How can you do that? I'm going to tell you how. Look, here is the idea. The idea is that here I'm gonna if I put here 5 volt, then because these are output, as I told you, that's why I make them output, because here, so if I want to scan the first 2 columns, I'm gonna put 5 volt here, 0 volt, 0 volt, 0 volt. Is that okay? Assume the switch is connected is here, the short circuit is here. Is that okay? So what's going to happen is that, so here what now I'm scanning, or I want to check if the switch you are pressing is in column 0 or not, right? So the way I'm going to do it is I'm going to put here 5 volt. Is that okay? For sure, as you see here, and then I'm going to read the input. If I find the input 0, 0, 0, 0 volt, okay? Where the 0 should come from? Okay, because I didn't tell you there is a resistance here and the ground, resistance and the ground, resistance and ground. Anyway, so if there is no 5 volt coming from the column, so actually what you are going to get here, you are going to get 0 volt. So if I find 0 volt, 0 volt, 0 volt, that means the short circuit is not in this column. Why? Because if the short circuit is here, I would the 5 volt would be seen here. So if the short circuit is here, I would see 5 volt here. If it is here, I would see 5 volt here. Because there is no 5 volt anywhere, that means there is no short circuit. This column is not shorted with any column. Makes sense? Okay. Any questions? So now I am done with the first column. Now that's why I'm saying I'm doing like search, or I'm doing scanning, because I don't know. Now I'm going to try the second one. So here I'm going to put 0 volt, then I'm going to here put 5 volt. And then I'm going to repeat again. If I find all of them zeros, that means it is not in this column. I have to try next one. Okay? So I'm explaining the idea verbally, but I'm going to show right now how I'm going to write the code to do that. The code is going to do that. Okay? So here I'm going to put 0 volt. Here I'm going to put 5 volt. Is that okay? It's still 0, 0, 0. So it's not here. Okay, when I come to here, the last one here, 5 volt, and there is a short circuit here because you are pressing here. So actually, this one is going to be 5 volt. You understand what I'm saying? Okay, so now I know. Once I know what is the column, once I know what is the row, now I can identify what is this key. Okay, because as you see here, guys, and this is how the function is going to work. If you're pressing this key, so I'm going to return a number 1. So this key number 1. If you press this key, the function is going to return a number 2, return a number 3, return a number 10, A is 10, return a number 5, 6, 5, 6, 11, okay, and so on. 0 here, and so on. So here, I need to know which key you are pressing so that I can return this number as you would see that. Yes, sure. Okay, that's number 1 is the software or the code I'm writing. Okay, we only press 1. Okay, so now if the user is going to press 2, okay, so based on what I taught right now, or based on the algorithm I explained right now, is that the first one, once, and that's what you are going to see right now when I explain the code. Okay, the first one, once the code finds the first one, is going to return. It's not going to continue. You understand what I'm saying? So for sure, you can modify it. Here I'm teaching a basic keypad. You can modify it so that you can make it advanced. And this can be, by the way, one of the projects you can make. You got what I'm saying? But if you connect, that's a very good question. What happens if, for example, I connect this one, for example, and I connect this one? Again, I'm doing scanning this way. As you will see right now in the software, on the program I'm writing, once I find this one, okay, I'm going to just take this one and return. I'm not going to continue scanning. Okay, because you are supposed to press only 1. You got it? Anyway, you can modify it if you want, for sure, to make it more advanced. But anyway, so now, as I made it clear last time, guys, and that's what you are going to do tomorrow, and this is my concern for tomorrow. The keypad is not connected to this microcontroller. It's connected to the other microcontroller. So if you look, we have another microcontroller here. So actually, so as I told you, we need 8 pins. Actually, there are already 2 connected. So there are already 2 connected, and the same 2 are connected here, by the way. That means if you want to use the keypad, you cannot use these 2 unless you change the connection. For sure, you can do it if you want to change the connection. But anyway, so now you need to connect 6 wires, 6 external jumpers from here, because let me make it very simple, very clear. This one here, guys, is connected here. Somewhere here. Why? because for this processor. Okay, so now I want to use this one. All what I'm gonna do, I'm gonna connect wires here, 6 wires, and that's what you have to do tomorrow in order to be able to use this keypad. Okay, and I made it very easy. It cannot be easier than that. So I have a figure here to show you how. Yeah, so I have here a figure to show you how you can connect it. Okay, so look at this figure here. Okay, so again, we need 6 pins. I am the one who selected this 6 pins. Okay, it was my choice. I selected the 6 pins that don't interfere with other devices, so that you can use the keypad and the other device. That's why I selected this one here. I selected this one. I didn't select this one because if I selected this one, you cannot use the LED. So this was my selection. I selected this one, okay, so that you can use a speaker, still you can use the LCD, okay. Still you can use the LEDs, okay. Also, I selected this one is already connected. You don't need to connect this one. That's what I told you. So row 0 and row 1 is already connected. You don't need to worry about these two. Okay. Only the ones in red here you need to connect them. So all what you have to do, very clear, very easy. You need to count from here 1, 2, 3, 4, and here number 4 here you have to connect it to BA10. You have to look at this figure. You find BA10 is the second one. So all what you have to do, you have to make a wire from here to the second pin here. Okay, this is for one wire. You can do the same for the other wires. Very easy, right? Number 6 here, I'm telling you, this one should be connected to BB4. Look here, where is BB4 here? BB4 here is this one. So you need to connect the wire from here to the last pin here. Okay, guys? Again, after you do the connection, if you want to make sure if your connections are correct or not, I give you, this is a program I'm going to teach right now. I'm sure it is working. It's on the course website. You can just run this program. I'm going to tell you what this program is doing. Okay, you can just run this program. If this program works, that means your connections are correct. If it doesn't work, so something wrong either in the connection, in somewhere, something is wrong. You understand what I'm saying? And that's what you have to do for tomorrow's lab. You can start with this one, run it, make sure it's working, and then modify it. Very easy, very simple. Okay, any questions? Okay. Anyway, so now I'm gonna teach 2 things now, guys. What I did, number 1, I explained how it is connected. I explained how can we program the keypad. Now I'm gonna explain, number 1, how I'm gonna write the software, the code. Also, I'm gonna explain how can we use it. If you wanna use the keypad, similar to what we did in the LCD. You remember in the LCD, what did I tell you in the LCD? Number 1, you need to call a function initialization one time. And then you have 3 functions. You can 3 or 4 functions, 3 functions, right? 1 for instruction, 1 for character, 1 for a complete message. That's it. That's it. I explained everything, but at the end, you have 4 functions you can use. Okay, cannot be easier than that. Same thing here, but here we have only 2 functions. Only 2 functions. 1 function similar to what we did before. 1 function. So I'm gonna explain it in details, but let me go to the conclusion first. The conclusion is that if you want to use the keypad, you have only 2 functions. Okay. The first function is initialization, as you see here. Initialization. Okay. I'm gonna explain how it was made. Okay. So this one should be only one time before you use the keypad. Before you use the keypad, you have to make sure you do initialization. This is number 1. Number 2, every time you wanna read a keystroke. Every time you want to read a keystroke, just to call this function. That's it. Just to call this function. Read keypad. Is that okay? And you already have this function. Okay. Just read this function. Once you read this function, what this function is gonna do is, number 1, if you are not pressing, it's gonna wait until you press. Once you press, it's gonna return. So this function is not gonna return until you press. Okay. Once and this function is gonna return a number from 0 to 15. Okay, to indicate, or this number should tell which key you press. Is that okay, guys? Okay, now, for sure, I'm gonna explain how I programmed this one. I'm gonna explain how I programmed this one. But let me first focus on how can you use. Okay, so in order to use the keypad, it cannot be easier than that. Number one, you call this one only one time for initialization. Every time you wanna read a character from the user, or you wanna read a keystroke, just to call this function. This function is gonna return a number from 0 to 15. That's it. So what I did here in this program, and for tomorrow's lab, you have to start with this one and you have to modify this one, as I'm gonna explain right now. Okay, so let's see how it works. Here, you have a while loop. Let me tell you how it works. So what's gonna happen here, guys? Number one, I'm gonna call this function. This function is gonna wait until you press. Once you press, so this function is gonna return a number from 0 to 15. So what I did here, guys, I said if the number is between 0 to 9, so what I'm gonna do here, I'm gonna send this number plus 30 to the LCD. And then again, in order to use the LCD, you have to initialize the LCD. Why you added 30? I said it last time. If you want to display number 0, you should not send 0. You have to send the ASCII of 0 to this function. Okay? And 0, the ASCII of 0 is actually 30 hexadecimal. The ASCII of 1 is 31 hexadecimal, and so on. So any number you have to add 30 to convert to ASCII, and that's what I did. So here, what I'm saying here, guys, is I'm gonna read this one, and then after that I'm gonna check what key you pressed. If you press a key between 0 and 9, so I'm gonna display the same key as you see here. I'm gonna display the same key. So if you, as you will see right now in the video, okay, if I press 0, you are gonna see on the LCD you can see 0. If I press 1, you are gonna see 1 on the LCD. By the way, this is also required in tomorrow's lab, so you don't need to modify this one. This is already one task in the lab. You don't need to modify this one. Is that okay? Now, also, what I did here, guys, as you see, now I'm gonna check. If you give me a number from 10 to 13, it's gonna be A, B, C, D, I guess. Let me see here. We have here, it's what is written A, B, C, D. Okay, and then we have hashtag, and then we have asterisk. Is that okay? So this is 10, 11, 12, 13. So if you press one of these ones, I want to display A or B or C or D. Is that okay? And that's what I'm doing here. That's what I'm doing in this program. Okay. So what I'm doing in this program, as you see here, if you press between 10 and 13, so this time I'm gonna add 55. Again, why 55? Because if you go to the ASCII of A, okay. So if I add 10 plus 55, but 55 here, by the way, it is decimal. Anyway, you can see what is the equivalent in hexadecimal. This is not a big deal. So anyway, so if you add 55 here, I'm gonna get A to 10. So if I add, because I'm gonna get 10 here, 10 plus 55, I'm gonna get the ASCII of A. Okay. So this one here, guys, if I press A or B or C or D, so actually you are gonna display A or B or C or D. Now, if I get 14. If you get 14, what it means? 14 means you press asterisk. Okay, so in this case, I'm gonna say display asterisk. If you press hashtag or bound sign, so in this case, it's gonna display this one. Okay, so what this program is doing is whatever key I press, I'm gonna see this key on the LCD. Okay, before, let me show you the video before I explain how you are going to modify it for tomorrow's lab, okay? So, where is LCD here? Hello. I don't know. I'm not seeing everything, but let me see if I can go to the. Is there a way I can go to the library here? Okay, let me, oops. Okay, maybe this one has everything. Anyway, I'm not finding, maybe I put it in a different place. Anyway, I'm not finding it here, but anyway, I already explained what you should. I'm not finding it here. I don't know what's wrong. I will check it again. But anyway, I told you what should happen anyway. So what should happen is, what if you run this code at home is, this is the LCD. LCD is here, the cursor is here. If I press number 1, you are going to see number 1 cursor here. If I press A, you are going to see A and the cursor here. If you press asterisk, so asterisk is going to be and the cursor. Is that okay? Okay. Okay. Now, how can you are going to modify for tomorrow's lab? Okay, for tomorrow's lab, what I told you is, if the user press a number from 0 to 9, so you have to display the number, the same. You have to display the same number, and this is actually what is done here. So this task already done. So this is the first part. This task already done. Is that okay? Now you need to modify this part. How can you modify this part? I'm going to tell you how. Very simple. What I'm saying, if the user press A, when you press A, that means you are going to get number 10. So after you here, you need to check if temp is equal to 10. If it is equal to A, you have to do a certain command. If it is B, you have to do a certain command. If 10, 11, if it is 12, you have to do a certain command. 13, you have to do a certain command, and so on. And last time I explained all the commands you need for tomorrow. Okay, even backspace. I explained last lecture. I explained even how can you do backspace. That's what you need to. So all what you have to do here, you need to modify this one. You have to say else if temp is equal to 10. And then here you have to write the command. You have to remove this one. You have to write the command here that is related to 10. And then you have to say else if temp is equal to 11. And then here you have to write the command related to 11, and so on. Okay, guys, any questions? Okay. So now I have explained, number 1, how, if you want to use the keypad, how can you use it using these 2 functions. Even I explain how can you do tomorrow's lab. You can start with this one. You make sure you need to make sure this program is working, to make sure you did the connections correctly. Okay. What I'm going to explain right now is I'm going to explain how I made these functions. Here. Okay. So let's start with the first one, keypad initialization. So what kind of initialization I need? Very simple. I have 4 and 4. So I have 4 pins input. I have 4 pins output. That's it. So all what I need to do is I need to configure these pins input and output. That's it. You got what I'm saying? So if you go to the keypad initialization, you will find the code for that. So yeah, this is the keypad initialization. So here, because I'm using port A and port B, so I have to enable the clock for A and B, and then I have to do, as you see here, I have to do the initialization input and output. So here, this is for input, and this for output. Oh, this also input. I think this is output, I guess. Anyway, so I did input and output for the all the pins. I think this is mistake. This should be output. But anyway, that's easy. Already we did it 1 million times. So is that okay, guys? So that's all the initialization here. We have 8 pins, 4 pins input, 4 pins output. This is the first thing I taught in this chapter. Is how can you configure a pin input or output? Any questions about this part? Okay. Regarding the other function, how I made it. Okay, the other function I made it this way, guys. I told you we need to do scanning. I need to do scanning. Okay. However, before I do scanning, I want to make sure first you are pressing any button. Okay. Before I do scanning, I want to make sure that a button is being pressed. Okay. So how you made it, as you see here, in the very beginning of the code, you find something. This is the first part in the code. So in the first part of the code of this function is I want to see if you are pressing any button. So the way I do it, as you see here, I put 1 1 1 1 1. You get what I'm saying? Just to want to check, and then I'm gonna read the result. If the result is 0 0 0 0, what it means? it means you're not pressing any button. You got what I'm saying? Because if you press any button here, I would see 5 here. You got any button. You got what I'm saying? That's exactly what it is. So as you see here, guys, in this part here in the columns, I put 1, 1, 1, 1, 1. Okay. And then here, I'm going to say, I'm going to make while loop. I'm going to make while loop, as you see here. While this one is 0, this one is 0, this one is 0, and this one is 0. While all of them are zeros, as you see here, all of them are zeros, so I have to keep looping. That's why I told you, when you call the function is going to wait. If you're not present, it's going to wait because of this part of the code. Because once you call the function, if you're not pressing any button, the function is going to keep looping here, because this is while loop until you press any button. Is that okay? Once you press any button, I'm going to start scanning. Okay. As I said before, the way I'm going to do scanning, I'm going to do column by column. So I'm going to put here 1, 0, 0, 0, 0. And then if the result is 0, 0, 0, so that means it is not in this column. I have to move to the next column. This is a related code is here. So the related code here, as you see here, I'm going to put here one column. I'm going to put 1 in column 0. And then after that, I'm going to check the rows. Okay. If I find that the first row does not equal, first of all, look here, guys. If here in this column, in column number 1, we have here, let me check. The first one here, it should be number 1, number 2, sorry, number 4. So it's actually 1, 4, and then we have 7, we have asterisk. Okay, guys. So what I'm going to do right now, I'm going to put here 1, and then I'm going to see the rows. If I find this one 1, so that means I have to return 1, right? If I find the 1 is here, so that means I have to return 4, and so on. Okay, that's exactly what I did. Look here, guys. So here I'm going to put 1 in column number 0, and then I'm going to check the first row. If the first row is not 0, that means it is 1. Okay, that means you are pressing which button? So if I put here 1 is here, and if I find this one is 1 here. Okay, so what I have to return, I have to return number 1, and that's what I did. If you see here, I'm going to say break A. A is actually the return value. So that's what I'm going to, so then I'm going to say break because I'm done. I'm not going to continue. I'm going to leave. I'm going to leave the loop. Okay, so I'm going to say just break. I am done, and then I'm going to return A. Okay, if not, if this one is not true, so I'm going to check this one. If the second row is equal to 1, so I have to return 4. If next one, so I have to return 7. If next one, so I have to return 14, which is asterisk. Okay, guys. And then I'm going to repeat this code again. I'm going to repeat the same code, but what I'm going to change this one in 0 and 1. This is number 1. Number 2, I'm going to change these numbers. Okay, the numbers for the next column is 2, 5, 8, and then 0. Okay, that's exactly what I did in the next part. So in the next part, as you see, okay, and that's what I did here. I have to look, I have the first one, I have to put 0 in the first one, and then I have to put 1 in this one, because the first one here, this one. So I have to make sure this one, I'm going to make it 0, and then I'm going to put 1 here. Okay, that's exactly what I did here in this code. Okay, guys. And then now I'm going to check rows, row by row. Okay, if I find the first row is 1, so I'm going to return 2. Second one, 5, 8, 0. You got it, guys? Any questions? Okay. If not, so I have to do the next one, and so on. That's why if you look at the code here, yeah, for this function, if you look at the code, as I told you here, yeah, so here I have to do 1 by 1. So here, this is the code for column 0. Then I have to do column 1, and then I have to do column 2, and then I have to column 3. Once I find something, I'm gonna break, go outside. Once I go outside, now you are gonna return. So as you see here, I'm gonna return A. Okay. Any question? Well, I did here also some code, because if you press and you keep pressing, listen to me, that's very important. If you press and you keep pressing, do you want to take it like you, for example, if I press number 5, You want to take like only 5 one time, or it's going to be 5, 5, 5, 5, 5. You got what I'm saying? So the way I did it here in this part, I'm going to wait until you release. That means if you press, okay, and you keep pressing, you are going to stay in the function here. Once you release, I'm going to return it from the function. You got what I'm saying? I did it this way so that in order to get number 5, you have to press 5 and then you release. If you want to enter another 5, you have to press and release, okay? If I want you to play, guys. You have the code, you just play with this code, just remove this part and see what's going to happen. What's going to happen is that if I go to the last here, the last one here is a program. Yeah, if I look at, if you look at this program here, you are pressing 5 and you are holding. So you're going to get 5 and you display 5. And then you are going to come here, go again, you get another 5, come again, get another 5. You got what I'm saying? So I'm holding. So you are going to call this function multiple times. Okay. I don't want to make it this way. I want to make it, if you want to enter 5 and 5, so you have to press 5, you release. Press 5 and release. That's why at the end, I put a code here at the end. Yeah, I put code here in this code. I'm gonna wait. Until there is no you are not pressing any button. Any question, guys? Okay, great. So that's it. So again, I am done with the keypad. You should understand how it is connected. You should understand the idea, the interesting idea about creating like something like a grid. You should understand why we made this way, and also you should also know how can you, if you want to use the keypad, you just have two functions. You can just use them. Okay. Even you can, even if you want to do something different, you can even create your own function, because I already explained how I made this function. You get what I'm saying? So even you can modify them, you can create something different if you want to use the keypad in a different way. Any questions? Okay, good. The last part here I want to talk about it before I move to chapter 4. We need to convert the binary to decimal and decimal to binary. I'm going to tell you why. Okay, so let me explain. Okay, let me explain it in one slide here before I give you the details. Look here, guys. If you have a number here, something like, as I explained to you before, for example, 1111111. Okay, so if you have a number like this one, and I want to display this number to the user. Okay, so I have a number like this one, and I want to display it to the human, to the user. You know, from what I taught before, this number is actually 255. Is that okay? So if for sure, I'm not going to display this number in binary, because humans don't use binary. They use decimal. You understand what I'm saying? So this is the main point. The main point is that computer is going to give you binary numbers. So you did a certain operation, and then you have the result. Okay, this is the result. Your microcontroller is going to give you the result in binary. Is that okay? Users don't like or don't understand binary, so you have to display this way. As I said before, this is like a translator. Okay, we have our own language. The machine has its own language, so I need to translate. So actually, what should happen is that if I want to display this one on the LCD, for example, or something else, just for now, let me talk. It's almost the same idea, but let me talk about LCD for now. Okay, so I have to write a program here. Okay, and then what this program has to do is using this one, I should do some operation in order to get to 5, the individual digits. Is that okay? So given this binary number, I have to do some operation in order to get 2 and 5 and 5. And then I have to add here 30, add 30, add 30. And then I have to send this one to the LCD, send this one to the LCD, send this one to the LCD, so that a human can see 255. You got it? So now you understand why we need If you get a number from the computer, it's going to be number binary this way. If I want to display it, I have to get these digits, okay? And then I have to convert them to ASCII and then send them to the LCD. Yes, sure.
For this whole operation, you're never going to add 55 like you did earlier because you want it exclusively in base 10, so you'll never have a reason to add 55.
Yes. Yeah. So the question here, because we are using numbers from 0 to 9, from 0 to 9. Is that okay? If you have number 0, the asking 0, you add 30. If you have 1, you add 30. You got what I'm saying? But if I want to convert 10, if I have number 10, if I want to convert it to capital A, okay, go and see what is the asking A. You will see the difference between them, 55. But 55 decimal. That's okay. But anyway, it's not a big deal. 30 here is hexadecimal. It's not a big deal. You got what I'm saying? Anyway. So now everything looks okay. The only difficulty or the only something is missing here. Given this one, how I can get these ones? So this is the question. This is a question mark here. I'm putting a question mark. How I can do that? You understand what I'm saying? Okay. So actually, the way you have to do it is, so if you have a number, and I want to display it, number one, I have to extract the digits from this number. Extract the digit. The way you have to do it, I think I explained it before, I guess, but anyway, you have to divide by 10. You have to divide by 10. So I'm going to tell you the idea. The idea is that, for example, let's have any other number. For example, you have 3721, something like that. You have this number in binary. I'm writing it in decimal just for us. You get what I'm saying? But it's in binary. Okay. Anyway, so if you have this number and I want to extract these digits, how I can do that? Simply, what you have to do is that when I divide this number by 10, I'm going to get two things. I'm going to get a remainder, and then I'm going to get a quotient. The remainder is going to give you 1. So now I got this one here. The quotient is 372. You got what I'm saying? And then I'm going to get this one. I'm going to divide it by 10 again. So this one is going to give me a remainder is 2. Wow, I got the second one. And now the quotient is 37. Then I'm going to divide this one by 10 again. Once you divide this one by 10, so now you are going to get the quotient is remainder is 7, the quotient is 3. Is that okay? If you are sure you already got one digit and that's enough, yes, you can continue, you can stop there. Sometimes the people are doing, I'm going to keep dividing until I find the quotient is 0. For example, here the quotient is 3, right? So I can take this one and divide it again. So now I divide this one by 10. I'm going to find the remainder is 3, the quotient is 0. Once I find the quotient is 0, that means I'm done. I am done. You got the idea? So the idea here, you have to keep dividing. You have to divide by 10. Every time you divide by 10, you are going to get one digit. You have to be careful. Why? Because the digit you are going to get should be from the right to the left. So when I display them, I have to display them left to right. Otherwise, if the number is 31, you are going to display it 13. You are going to switch the numbers. You got what I'm saying? So you have to be careful here. What I'm saying, every time you divide by 10, you are going to get some digits, but the first digit you are going to get is actually the last one you should send to the LCD. You understand what I'm saying? So this one should be sent first to the LCD. Any questions? Now the question is, okay, so tell me in C language how I can divide by 10 and I can get remainder and quotient. How I can do that? I'm going to tell you how. In C language, when you do percent, this percent actually is going to be modulus, mod or modulus, or this one is going to give you the remainder. So here, if you do in C language, if I do 3721% 10, so actually I'm going to get number 1. Okay, because this one is going to give you the remainder. Also, when I do 3721 and you do the normal division by 10 and you store the result in an integer, so in this case, you are going to get 372, the quotient. Okay. So now we are going to use 2. We're going to use percent to get the remainder. We're going to use the normal division, but we're going to store the result in integer to get the quotient. Is that okay? Any questions? Okay. So what I said like right now, guys, I'm making translation. Computer is gonna give you the result in binary. I have to do some processing to the number I'm gonna get from the computer so that human can see it, can to decimal. Human can understand it. Is that okay? Now, okay. Now what I'm gonna do right now, I'm gonna explain the opposite. What do you mean by the opposite? I'm gonna tell you what I mean by the opposite too. This operation, what I did right now, we convert the binary to decimal. We need to convert the binary to decimal. Now I'm gonna do the opposite. How can you convert a decimal to binary? Now I'm gonna, it's here, like you translate from binary to decimal. Now we need to translate from decimal to binary, right? So it has to be two ways. I have to translate from microcontroller to human. Now I'm gonna explain how can I translate from human to microcontroller. Is that okay? For example, if you want to get a number from the user, you are going to ask the user, please give me a number. Okay. For example, I want to get 3 numbers from the users. As I have just explained right now, you have to call the function, you have to call read keypad, right? You have to call it 3 times. Every time you call it, you are going to get one number from the user. Is that okay? For example, the user enter 3 or the keypad give me 3. I'm gonna then you enter 7 and then I got 5. What this means? So that means the user typed, the human typed 3 and then 7 then 5. So the user means my number is 375. Is that okay? So the question is that given these individual numbers, I'm going to get individual numbers from the keypad, given this individual number, how I can get the equivalent binary for 375. You understand what I'm saying? This is what I mean. You want to translate from decimal to binary so that the computer can use it. You understand what I'm saying, guys? Okay, so yes. This is it's somehow funny because this is a question of the first grade or second grade. So for first grade or second grade students, we tell them any number here, this number are in ones, this number in tens, this number are in hundreds. And one of the question, if you remember in the second grade, okay, they actually give you three digits this way, and they told you now you have to mix the number, okay? And the way you have to do it, which is very simple way, is you are gonna multiply every number by its weight. So here I'm gonna multiply 3 by 100. Sorry, plus 7 times 10 plus 5. This should give you 735. Yes, that's exactly what I'm gonna do. You got what I'm saying? So here, that's what we call, we convert the decimal to binary. Okay? So again, what I'm gonna do right now here, guys, what I'm saying, when you ask the user to enter a number, the user is gonna give you individual numbers. You have to combine them together to make a number, binary number. You can then, after that, you can use this binary number. You can use it in multiplication, in division, you can do whatever you want. Okay. Now, so I explained now the idea of how can you convert the binary number to decimal to binary. Now I'm going to put both of them in one program to see how can you use them. Okay, very important. So that's what I'm teaching here. That's what I explain. Now I'm going to show one program here. Look at this program. I'm going to check again. I'm sure I uploaded the video. I'm sure, but let me see here. I'm not, is that everything? Maybe that's everything. Looks like everything, but let me see. Sometimes I put it in the wrong place. So let me go to this one here. Anyway, it looks like I need to check it. I'm sorry. It looks like I took videos and even I made some videos for chapter 4. But it looks like either. Yeah, it's not here somehow. The LCD is not here. Okay, anyway. Okay. Okay. So anyway, it's not here. I will check it again. Okay. So now I'm gonna show how I'm gonna tell you how this program works, and you already have the program, you have the board, you can try it. So this program should work this way, guys. Number one, I'm gonna display in the very beginning, I'm gonna display something like that. For this not displayed. Okay, in the very beginning, I'm gonna display number question mark. Is that okay? This number one. Then the user is gonna enter 3 digits. Then the user is gonna enter 3 digits. Is that okay? After the user, every time, for example, when I press 2, you have to show here 2. When I press 5, you have to show 5. If you press 0, you have to press 0, show 0. Is that okay? Then after that, after you enter this one, the computer has to display this one. For sure, because 250, as I have just explained right now, you are gonna get 2 and 5 and 0. So you have to convert this decimal number to binary. Then after you have a binary number, you are gonna double it. After you double it, you have the solution, but in binary. Okay, and so in order to display it here again, you have to convert the binary to decimal. That's why this is a very good program to understand why you need to convert the binary. So I'm gonna run the program step by step. So now I'm gonna remove this part here. Look here, guys. So as you see here in this program, as we did before, I'm gonna make a message. I'm gonna call it number question space. Okay. Then as you see here, because I'm gonna use the keypad, also I'm gonna use the LCD, so you have to do the initialization. That's okay. And then you have to display the first message here. So after you display this first message, you are gonna see something like that. Number question mark space. Is that okay? Here I'm asking the user to use the keypad to enter number. So after this one, now I'm gonna put the keypad, waiting for the user to input a number. Is that okay? So that's exactly what I did. So here what I did, guys, here. Then after that, I'm gonna call this one, this function is gonna wait until you give me a number. Once you give me a number, I'm gonna store it in digit 3, okay? And then I'm gonna display it. So if you hit 2, so you are gonna see 2 immediately, you are gonna see 2. Once I get 2 from you, I'm gonna just display it. You got what I'm saying? So I'm gonna repeat this one 3 times. So here I'm gonna call the function again. I'm gonna get digit 2, right? And then I'm gonna display it. Here in this example, you input 5. Okay. And then I'm gonna call it again here. Okay. I'm gonna store it in digit 1. So now what happened now, I have 250. But again, I have 250 as 3 digits. Digit 3, digit 2, digit 1. Is that okay? Now I need to combine all of them together to convert them. Computer cannot work on, so I need to combine them to make it 250 as a binary number, and then I'm going to use the 250. Okay, how I do that, as I have just told you here. Before I do that, I wrote this instruction so that I can move the next line. So this instruction here, just to move to the next line, as I explained last time, and then I'm going to display the second one. So this one is not displayed yet. Okay, so here these 2 instructions, one of them to move to the next line, the other one to display double. Now I'm going to do the calculation, and then I'm going to calculate. I'm going to give you the double value. Okay, so as I have just told you, digit 3, I'm going to multiply it by 100. Digit 2, I'm going to multiply it by 10, and then I'm going to add to digit 1. Now I have a binary number here. Okay. Now, this is binary number, now the computer can use it in whatever you want to use it. For example, here, I'm going to multiply it by 2. You see, so I'm going to multiply this number by 2. Okay. So now I have 500, but just in binary. 500 in binary. Okay. So now I want to display number here. I want to display this one number. Okay. As I told you, how you can display it, you have to get the digit. You have to extract the digit by dividing by 10. That's what I did. So here, I'm gonna do, as you see here, guys, it is 500 So first of all, here I'm gonna make percent 10. So once you do the percent 10, so I'm gonna get this one. So this one will be 0. Is that okay? And then here I'm gonna get the quotient. So this is 500. When you divide by 10, I'm gonna get here 50 because number is integer. Is that okay? Then now I got one digit and I have 50. I'm gonna divide again by 10. So this one is gonna be 0 again. And now I'm gonna divide it by 10 and then get the quotient, which is 5. I don't need to divide again by 10, or anyway, I just did it. You don't need, but anyway. So when I divide by 10, the remainder will be 5. So now I have the solution, but just in digits. I have digit 1, digit 2, digit 3. Is that okay? Now I want to display them. So to display them, remember what I said. You are going to get the numbers this way. So when you display them, you have to display them this way. Makes sense? So you are gonna get this one, and then this one, then this one. So when you display, that's exactly what I did. So when I display them, digit 3 plus 30 display. So here I'm gonna display 5. Then I'm gonna display 0, display 0. Any questions? Don't be shy. If you have any question, raise your hand. Okay. So you should be able to now to understand how can you use the keypad, how can you understand the LCD. You should understand how I use their multiplication. I have to multiply every digit by its weight, to convert decimal to binary. Also, if you have a binary number like number here, have a certain number, okay? How can you extract the digits? This is a binary number. I want to display it here. In order to display it here, you have to extract the individual digits as I did this way, and then you have to add 30. Any questions? Good. So I didn't finish chapter 3 yet. I didn't explain 7 segment and other stuff. But as I told you, I'm going to move now to chapter 4, okay, for 2 reasons. Number 1, because we need it in next week lab. Number 2, because the part I'm going to teach in chapter 3, I need it also in chapter 4 because it's almost the same, but here I put it in the main. In chapter 4, I put it in interrupts. So I think it's very useful to teach them together. Because I found it very useful way to teach it because it's almost the same thing. But here I'm going to put the code in the main. Here I'm going to put it in interrupt. So that's why I'm going to move to chapter 4. Okay. Any questions? Okay. Okay. Chapter 4 is about interrupts. Please, this is a very important topic. Very important topic. You should understand the concept of interrupts. You should understand what do you mean by interrupts? Why you need them? Why you are saying this is important topic? Simply because it's impossible. It's impossible to make a good program or a real application without interrupts. It's impossible to make a big program without interrupts. You understand what I'm saying? Very important, very useful. So I'm going to go through, I will do my best to understand this topic because interrupts are extremely important, okay? There is no way to make a real application without interrupts. There is no way, okay? For sure you'll understand why, okay? So I'm going to divide it this way, okay? Number 1, I'm going to explain the concept. I will do my best to teach the concept. Very important to understand the concept itself. What do you mean by interrupts? Why we need them? And please, if you have any question, you can interrupt me and you can ask questions. Okay, so you are allowed to interrupt me. I'm totally fine. Okay, but anyway, then I'm going to focus on programming. What should I do to program interrupts? Then I'm going to take 2 sources of interrupts because, as I'm going to explain, we have different sources of interrupts. Okay. Why we use the English word interrupt? For sure, we use it for a reason. Someone should interrupt someone else, right? Otherwise, yeah, we use the English word interrupt because someone will interrupt someone else. That's true, and that's what we'll do now. But anyway, so let me explain what do you mean by interrupt. Look at the definition, try to see word by word what I mean. Interrupt means an event that requests the CPU to suspend the program execution briefly and run a subroutine. We call it interrupt service subroutine. So now I said two things important, very important. Number one, there should be an event. That's true. What do you mean by event? Ignore it for now. I'm going to tell you what I mean by event, because every interrupt has different event, but there should be event. I'm going to for sure elaborate later what I mean by event. Okay. So there is an event, and because of this event, CPU has to suspend the program briefly and go execute a subroutine. We call it interrupt subroutine, and then go back. Okay. I'm going to elaborate more. Very important to understand the concept. Very important. Look here, guys, what I want to say. What I told you so far is, look here. If you have a program like this one, move R010, move R115, and so on, okay? What I told you before, that's what we did before. After this instruction, we are going to execute this instruction. After this instruction, we are going to execute this instruction. Is that okay? That is conditionally true, not always true. Okay? Okay, so let me now make it more accurate. After execute this instruction, if there is no interrupt, microcontroller is going to execute this one. After execute this instruction, if there is no interrupt, microcontroller is going to come here. Okay? However, if there is an interrupt, so for example, after executing this instruction, there is an interrupt from one source, microcontroller is not going to execute this one. Instead, it's going to go execute a subroutine and come back to here. Is that okay? Let me say it again. After executing, that's what we did so far, okay? After executing one instruction, you are going to execute next one. After executing this one, you are going to execute next one. That's what we did so far. It's not very accurate. This is true if there is no interrupts, okay? What is more accurate is, after we execute one instruction, okay, if there is interrupt, hardware interrupt, microcontroller is going to go execute a subroutine for this interrupt and then come back to here. Is that okay? Just give me more time to make the concept very clear, okay? So, very important here, no comment to call the inter. I didn't write it. So someone can tell me, this is similar when you call a function. That's true. This is similar to call a function. However, when you call a function, you have to write an instruction to go to the function and come back. Is that okay? Here, I'm not going to write an instruction to call the function. Who's going to call the function? The event, hardware event. You got what I'm saying? So this is the concept itself is very close to calling a function, because you are going to do something and come back, right? The concept is very close to calling a function. However, if you call a function, you have to write a command to go call a function and come back. Here, you don't write a command, because who's going to call the function is the event. I'm going to elaborate more to explain what I mean by event, but for now, there is an event, okay? Because this event actually is different from one source to another. We have multiple sources. Is that okay? Yes. So an interrupt means an event has occurred and a relevant action should be taken. This is the meaning of it. An event happened, an action has to be taken. So what action you are going to take? Whatever action you are going to take, have to write here inside the subroutine. So every time you have interrupt, I'm gonna execute it's a subroutine. Every time there is interrupt, I'm gonna execute the subroutine. Is that okay? So for this interrupt, for this event, I have to do something. Yes, whatever you want to do, I'm gonna write it here in the interrupt subroutine. What do you want to do? Every time there is an event, what do you want to do? Just write it here. Any questions? Okay, I'm gonna try to make it more clear. For example, I can have, for example, an event, it can be like a signal coming from a device or sensor, okay? Or it can be a timer. So for example, and that's exactly, so I told you, this event is different it depends on the source. So at least now I'm going to explain in this chapter, I'm going to explain two sources of interrupts. One source is coming, you call it external interrupt. So external interrupt means we have a pin, external pin. Every time there is a rising edge on this pin, you want to trigger interrupt. This is the meaning of it. There is an external pin. Every time there is a rising edge or falling edge, trigger interrupt. Okay. This rising edge or falling edge, it can come from a sensor. Sensor is interrupting the microcontroller. Is that okay? For this one, we call it a timer. Timer. You can tell from the English name, timer. So I can tell the timer, please, timer, interrupt me every 1 second. So this is here, this one does not have a pin. This is something internal, CPU. So, and we have a timer. So the timer is gonna interrupt me after every 1 second. You got what I'm saying? But anyway, I'm gonna elaborate, guys. Don't worry. But at least for now, I'm trying to explain what do you mean by event. But event again is different from one interrupt source to another because we have several interrupt sources. Okay. So if you mean external interrupts, so in this case, event means there is rising edge came. Can come from a sensor, it can come from fire alarm, whatever. Okay. And we need to respond to it. Also for timer, here, this one does not have external pin. However, this one should interrupt me every certain time. You can control the time. Do you want to interrupt every 10 milliseconds, 20 milliseconds, and then whatever you want to do? I want to do something every 10 milliseconds. So I'm gonna program the timer to interrupt me every 10 milliseconds. Okay. Anyway, so for example, I'm just trying to give you example here to try to understand the concept or the idea. So the idea here, we have an external pin here. Every time, as I told you, every time there is a rising edge or falling edge, you are gonna trigger interrupt. Okay. I told you, what do you mean by trigger interrupt? It means I'm gonna execute a subroutine. That's the meaning of it. When you enter, every time you trigger interrupt, so we're gonna execute a subroutine. By the way, we use the term serve an interrupt means executing a subroutine. So this is expression we are using. So we are using the term you serve, the interrupt is served, or you are going to serve interrupt. You understand what I'm saying? So if you want to interrupt me, you are going to raise your hand to get my attention. Is that okay? You interrupt me. And then I'm going to serve you by listening to you and responding to you. Okay, so it's exactly the same thing. Okay. So anyway, so when I say there is an interrupt and we serve the interrupt, what do you mean by serve? I serve it means I'm going to execute its subroutine. Okay, guys. So very simple. So all the story is I have a subroutine. I have to write something in this subroutine, okay, related to what you want to do, related to what your application is going to do. And then every time there is an event, so the subroutine is going to be executed. That's it. I'm going to give you more details. For example, in this specific application, I connect here the external pin to a sensor. This sensor is going to sense a train. Every time the train comes, so here the sensor is gonna make a pulse this way, and here every time there is a rising or falling, this is something you can configure or you can program. Okay, so actually microcontrol, you're actually requesting interrupt. So every time there is a rising edge here, you are gonna request interrupt. Okay, when you request interrupt, microcontroller is gonna execute the interrupt by running its own subroutine. Every interrupt source has its own subroutine. Not all of them have the same subroutine. Makes sense, right? So every source has its own subroutine. So when this signal comes, I know in this application, when this signal comes, I know that train is coming, right? So, and I know the subroutine is going to be executed. So what should I do here? What should I write here inside the subroutine? What I have to say, I have to lower the gate. So I have to write a code to lower the gate. So every time there is an event like this one, I have to lower the gate. Maybe you can also you can make it up again, whatever. Okay, but anyway, so again, every time there is an event, we need to execute a subroutine. In the subroutine, I have to write a code related to what you want to do. Any questions? Okay, so all what I said so far, guys, is that microprocessor can give you a program You program, you write your program. Macro resource can leave your program to execute something and come back. Go execute something and come back. It's go execute something and come back. That's what X did. Is that okay? So now, very important. You told us this topic is very important and it's impossible. It's impossible to make a useful application without interrupts. That's true. So why this topic is so important this way? I'm going to tell you. That's what I'm justifying here. Number one, because of interrupts, we can better utilize the CPU. That means we can program big applications. Big applications. Okay. So what do you mean? I'm going to tell you what I mean. What I mean is that we created a delay before in chapter 3. You remember delay, this delay function, we did it before, okay? How we made this delay function? The way we made the delay function is that you are gonna call a subroutine. The processor is gonna do some looping. It's gonna loop for a certain time. Is that okay? So if you wanna make a delay for 1 second, as we did in chapter 3, you are gonna call a subroutine. The CPU is gonna count for 1 second. Gonna execute some instruction for 1 second. Is that okay? Is that a good idea? No, it's a very bad idea. Why is it very bad idea? Because the CPU is gonna be busy for 1 second. Is that okay? So what is the problem with that? The problem is that, guys, I want to make big application. In big application, you can run multiple tasks at the same time. If you keep the CPU busy just to take care of one task, what about the other task? That should understand now. Your program is not gonna be one task because of that's why I'm saying interrupts are very good or very important to make like big application, because now you can do multitasking. You can do several things at the same time. Okay, how can we do? Processor can execute only one instruction at a time. We agree on that. However, so for example, in the main program, and that's what we have done so far. In the main, that's what we have done so far. I can write one task. So task 1, I can put task 1 in the main program. Is that okay? And then I'm gonna put one task in interrupt 1. I'm gonna put another task in interrupt 2. I'm gonna put a third task in interrupt 3. I'm gonna put another task in interrupt 4. Is that okay? And then what happens is that here you are gonna execute task 1, and then you can briefly, if interrupt come from interrupt 1, here you run task 2, task 3, task 4, task 5. Is that okay? So processor can go execute it, come back quickly, go execute it, come back quickly, go execute, come back quickly, go execute it, and come back quickly. And again, because the processor is so fast, you are not gonna feel that task 1 is suspended. You're not gonna feel it. You are gonna feel you are running all of them at the same time. You got what I'm saying? You remember. There was a program, and I told you I'm gonna use it later. There was a program when I turn one LED on, and then the other I turn one on and leave the other one off, and then wait for some time, turn the second one on, wait for some time. And in the video, I made the time too short. So I'm gonna turn the first one on, okay? And then I'm gonna wait one microsecond or 1 nanosecond, then turn the second one on, and so on. So what did you see? What you saw is that all of them are on at the same time, which is not true, right? But because you are doing it very quickly, you are not gonna feel that one of them is turning on and off, on and off. You understand what I'm saying? It's the same thing here. Because of interrupts, I can make big programs. I can write, as I said here, in the main, that's what we have done so far. In the main, I can write only one task. Every interrupt, I can put another task. And then if the processor is fast enough, you're not going to feel anything. You can go execute, come back, go and execute. That's what we call multitasking. You understand what I'm saying? So because of interrupts, you can run several tasks at the same time. Okay. Anyway, I'm going to elaborate more. So here, what I'm saying here, guys, just to understand what I want to see here, when I want to make a delay, I call the function, I call it delay, okay? And what happened here, the CPU was busy doing the delay. Okay, this is it's not a good idea because if you have multiple tasks, you don't want the CPU to be busy in one task all the time, right? Because I want it to go and come back. Okay, so okay, tell me, can I make a delay in a better way instead of what I did in chapter 3? The answer is yes. How? I'm going to tell you how. Look here, guys. This is the main point. In chapter 3, who has to count for 1 second? CPU. The CPU has to make 4 loops several times to count for 1 second. Okay. If I can transfer this job or this test to an external device, the CPU is going to be free. I will be happy the CPU is free because the CPU can take care of other tasks. That's exactly what happens. For example, instead of using this function, I can have a hardware device, external hardware device. Then I'm going to tell this hardware device, please interrupt me every 1 millisecond. This time, who's going to count for 1 millisecond? Not the CPU, the external device. So what I did here, the task that was counting the time, this task was done by the CPU. Now I'm going to transfer to an external device. And then when you are done, just please interrupt me. You can say. So by this way, the CPU can be free. So here, for example, if I want to make interrupts every 1 second and 1 second, okay? What we did in chapter 3, the CPU has to count for this 1 second. Now, no, I'm going to ask the timer, please interrupt me every 1 second. Now I'm free. I can do whatever I want to do. I'm free now. You got what I'm saying? And when you are done counting, you just interrupt me. Now I can do 1 second is best. You got what I'm saying? So this is what, for example, this is how you should for sure, the picture is going to be more clear in the future as I teach more here, but at least for now, you should understand the interrupts can allow me better utilization of CPU, make big programs. And I explained what I mean by big programs. I mean, the CPU, you can run multiple tasks at the same time. CPU can take care of the LCD keypad, also can take care of, you have a fire alarm, you have serial communication, you have several things you need to do. CPU should take care of all of them at the same time, okay? Anyway, so also to understand the concept more, I have this slide. For example, if I ask you right now, I'm just repeating because I want to fully understand what I mean by interrupt, okay, why it's useful. Look at this test. Now, if I ask you to write a program to turn an LED on and off for 1 second, and also at the same time, I want you to read the keypad and display the result on the LCD. Based on the knowledge you have right now, can you do these 2 tests? This is like 2 tests, flashing LED, and also I want to read the LCD. I want to read the LCD and display on. I want to read the keypad and display it on the LCD. 2 different tasks. Can you do right now? For sure you can, right? You can, based on the knowledge you have right now, you can do either one of them, but you can do both. Okay, because of interrupts, you can do both. That's what I'm saying. Okay, so for example, what you have right now without interrupts, yes, I can turn LED on. The CPU has to count for 1 second, turn it off, count for 1 second, go to the beginning again. I cannot put the other task here, okay? With interrupts, all what I can do is the code, the keypad and LCD, I can put the code here in the main program, okay? This is, I can put here task 1 here, this is 1 task, and the other task, flashing LED, I can put it in interrupt subroutine. And I can ask the timer, to interrupt me every 1 second. So what this means? It means every 1 second, there is 1 interrupt. Again, what this means? It means every 1 second, I'm going to execute this subroutine. The event here, you want to trigger interrupt every 1 second. Is that okay? What it means? It means every 1 second, when you trigger interrupt, I'm going to serve the interrupt by executing the subroutine. You got what I'm saying? So what's going to happen is that, look here, guys. The CPU is going to execute the keypad and LCD. Okay, after 1 second, I'm gonna go exchange flashing. If the LED on, I'm gonna make it off. If it's off, I'm gonna make it on. So I'm gonna do this one and then come back to here. After 1 second, I'm gonna suspend this program. Go do this one and come back. Suspend this program. Go and come back. And again, because the CPU is very fast, you are not gonna feel here the keypad. Every time I press the key for the keypad, you will see everything is running at the same time, which for sure is not true, because you are gonna feel that. You are not gonna feel there is any suspension for the program here. You understand what I'm saying, guys? Here I give you example for 2 tasks, but actually you can use multiple, you can use several interrupts. So as I said, now your program is not going to be written only in one place. Your program, you have to write in the main program. There should be 1 task in the main program, and then you can have here multiple interrupts. Everyone can have 1 task and just to go and come back. But this way you can run multiple things at the same time. Okay. The other thing, another example here I want to teach here. So in this example was about the time. So in this example is about how I can count for the time. And instead of doing it by the CPU, we can have an external timer to do that. I'm going to give you another example to understand why interrupts are very interesting. Look here. For example, here in this example, guys, okay, this signal can come at any time. This signal can come at any time. Without interrupts, how I would do it? Without interrupts, the way you have to do it, you have to write a code. You have to check the pin. You have to continuously check the pin. You have to ask the pin, are you 1? No. Are you 1? No. Continuously. If you don't do that continuously, you may miss. I may miss this pulse. That's what this technique is called booling. Booling means you have to continuously check. So can CPU do anything else? Can the CPU do anything else? No, it cannot. Otherwise, you're going to miss this one. Continuously, you need to check it. Okay. So now what I can do is that now the CPU is free. I can do whatever I want to do. However, I'm going to ask the hardware. This is hardware. You don't need to write any code to check the pin. I'm going to ask the hardware, please, hardware. If there is a signal, okay, interrupt me. So there should be an external circuit that's going to interrupt the CPU. Without it, you don't need to write any code to check the pins. Okay. So here, yeah, so without interrupts, we call it booling. In booling, that means to avoid missing an interrupt, the CPU must continuously read the pin. The CPU cannot do anything else, okay? But if there is an interrupt, so CPU can do whatever you want to do, and then you can notify me when I'm done. So booling is not a good idea because you are going to waste the resources in checking infrequent but important events. Infrequent but important events. Okay. Just give me the last one here. Just 1 second. Okay. So here, just to understand it more, guys, that's what I'm saying here. Without interrupt, I have to write a code to do something like that. If I have to keep it checking this way, so the CPU cannot do anything else. Otherwise, if you go and do something else, you may miss this one. Because keep in mind, CPU can execute only 1 instruction at a time. This is a fact, okay? So a better way with interrupts, no, you are free CPU, you can do whatever you want to do CPU, and then, so you can do whatever you want to do here, and then when there is a signal, the hardware is gonna force the CPU to come to here, execute a subroutine, and then come back. So, and then I'm gonna write the code here. Any question, guys? Anyway. Hopefully this topic is very important. I'm doing my best to understand it. Very, very important. I started to teach it early. Okay. So anyway, I'm gonna continue. Maybe tomorrow I need to teach for 1 hour. Okay. So I need to do that so that you should be able to do for interrupts, because it's important. Number 1, we're gonna do a lab about interrupts in next week. Also, it will be in the test. In this tool, we'll also have interrupt. It's not difficult. Once you understand how you do things, everything will be okay. Okay, I'll see you tomorrow.